Alright, so the problem is that given X a non-empty set and YD be a metric space, the problem is that can we define a metric on X, which can be say that like inducing a metric on X from Y kind of thing, such that how it is defined, the metric is how it is defined. Look, d dash x comma y is equal to d fx comma fy. Okay, so now the problem is that is x d dash a metric space? We are given that f is a 1-1 function. Okay, fine, let's begin the proof. We will show the that xd dash is indeed a metric space. Okay, what properties do we need to solve for this? First, we will show that d dash xy is always greater than or equal to 0. It's a positive property, and which can be easily seen. What is this equal to? This is equal to d fx fy. Now, as d is always greater than or equal to 0, as d is a metric, thus one is satisfied. Now we come to the second property. What is that? We take second property to be symmetric, right? Right, second property we are interested in is the symmetric property. Symmetric property, and so for that we need to show that d dash xy is equal to d dash yx for all xy belongs to x. Okay, this is another also simple. Simply put the value of d dash xy. What is this? This d fx fy, which is equal to d fy fx, because d is symmetric. As we know, yd is a metric space. This is equal to, what is this? This is equal to d dash y comma x. Hence proved. Okay, sorry. Now we come to the property 3, triangle inequality. Okay, we need to show that this d dash follows triangle inequality, that is triangle inequality. What is we need to show that d x comma y is less than equal to d dash xz plus d dash zy for all xyz belongs to x. Simply put the definition. What is the definition of dx? That's not big deal. dfx fy. Okay. No, and we know that d is a metric, therefore d dash xy definition is df. According to definition, we have nothing done here. Okay, now fx, fy elements of y, we can just use triangle equality for d, because for d triangle equality is valid as d is a metric space. So we take here, we can use triangle equality in y, in yd, fz, fz, fy, which is less than equal to. Now again, what is according to the definition? This is d x z d dash plus d dash zy. There's nothing here. It's easy. Just we need to see this, that fz belongs to y. Okay, and we can apply triangle equality in yd space. That's all we have used. Nothing. Okay. Now we are on the last property, fourth property, and it goes like this: if d dash xy is equal to 0, if and only if x is equal to y. Okay, we go first with, okay, given that we will first prove we have to prove if and only if condition. We have to go both way around, but we will first go with the one way. So one first way we will go with, if we show that if we have given that d dash xy is equal to 0, to show x is equal to y. So given that d dash xy is equal to 0, that means we put just have put our definition here. This means that d fx comma fy is equal to 0. Just applying the definition we have used of d dash. Now since d is a metric, and if dfx comma fy is equal to 0, this will imply fx is equal to fy. Now here we will use the fact that f is 1 1. Here it is important, we haven't used a 1 1 of f until now, but for this property f 1 1 is important. Okay, since 1 fx is equal to fy imply x is equal to y. Okay, so we have proved it one way around. Now we prove another way around. Now we are given that x is equal to y, to show d dash xy is equal to 0. Again, simply we will put the definition of d dash xy, which is to show dfx comma fy is equal to 0. Now as x is equal to y, this implies fx is equal to fy. Hence dfx fy is equal to 0, which implies d dash xy is equal to 0. Hence proved. Thus we have proved that x d dash is a metric space. Here's where, how is d dash defined? D dash is defined as d dash xy is equal to d fx fy. What is f? F is a function from x to y, and very important property is that f must be 1 1. We only need 1 1, nothing else. If this happens, then x d dash is a metric space. Okay, now an interesting question arises. So we do have a metric induce x d dash, induce from y dash yd by f. A natural question arises, by f. A natural question arises, are x d dash and yd are equivalent metrics? What property does this share? No, these are natural questions. Okay, if you want to check out is it true or false, check the I have given some proof counter examples of for this. You can check out in the link in the description below. There is a link. Thanks.